Okay, thank you everyone for joining today's webinar series for state and local government. Today we're going to have some more of a technical deep dive into what you can do to utilize AWS, specifically around the ease of AWS deployments. With that being said, as we go through this presentation today, feel free to ask questions via the question console that you have through GoToMeeting or through chats. We have a few resources on this side that can answer them in real time, or we'll save them for the end to address during our question and answer session. With that being said, I'll go ahead and kick it off to Leo to start the presentation for today.
Hi everyone, my name is Leo Janowski. I'm a solutions architect here on the public sector team at Amazon Web Services, and I'm going to talk to you today about the ease of AWS deployments. So we're going to see how to deploy a CMS, which is Drupal. We're going to see how to deploy it both through Elastic Beanstalk, and then just to compare and contrast, we're going to see how to deploy it just manually on an EC2 instance. So before we do that, let's talk about just some basic foundational stuff with regards to Amazon Web Services. So Amazon Web Services ranges from different services all the way from lower level things like our global infrastructure, networking, compute and storage, all the way up to higher level services such as database services, application services, and deployment and administration services. So the most foundational AWS service is EC2, which is the Elastic Compute Cloud. EC2, you can think of it as basically virtual servers in the cloud. There are currently actually more than 27 instance types. Instance types are just different sizes of compute capacity, so there are different instance families. Some are optimized for memory, some are optimized for storage, for compute, for GPU processors. So you just pick and choose which instance size you need based on whatever the requirements of your workload or application are. You can boot EC2 instances in minutes or seconds, depending on the instances. You can launch anywhere from one instance to thousands of instances in minutes if you want. You can change your instance size as your requirements change. So, you can start off with, for example, a Drupal install that's pretty small, so you're using some smaller instance sizes. And as your website scales, you can add more instances. You can go to bigger instances as you need to. You only pay for the capacity that you use. So what that means is, by default, the default pricing model is on demand. You pay for by the hour per instance. So if you launch an instance for 10 hours or you launch 10 instances for 1 hour, it's going to cost you the same exact thing. In terms of operating system choice, you can run Windows or Linux, or actually I've seen FreeBSD on there as well. If it's a operating system with an open source license that's free, then you just pay for the compute time. If it is an operating system where there's a licensing component to it, such as Windows or Red Hat Linux or SUSE, for Linux distros, for most of them, you can bring your own license. So if you already have a license, you can bring that license with you, or you can choose to pay by the hour. For Windows, you can you pay by the hour, basically, for the license. You can choose to deploy your instances across any of our regions and availability zones that you would like. We currently have 10 regions. We have 3 regular regions in the U.S., so one on the East Coast in North Virginia, 2 on the West Coast, 1 in North California, 1 in Oregon, and we also have a region called GovCloud that's out in Oregon that is specifically designed for ITAR compliant workloads. You can also launch your instances into a VPC. A VPC is a virtual private cloud where you control the address space, the subnetting, the route table, and where those subnets can go, basically. So it's having a software-defined network on top of your EC2 instances. So as I mentioned earlier, there are different instance types and sizes. So these are the general families out there. General purpose instances are just the ones where typically you would start off with these, where they're good for an all-round thing, where for CMS, for example, or if you don't know where to start, I'd recommend starting small and starting with a general purpose instance. Then there are compute optimized instances where they're heavy on the CPUs, and these are great for example, web servers, app servers, Then there's a family of memory-optimized instances. So memory-optimized instances are great for things like relational databases, such as MySQL or Oracle or Postgres or SQL Server. Then the next instance family is the I2 family. These are storage-optimized instances. They have big and fast SSDs on them. They are great for things like running NoSQL databases on EC2. Then there's a type of GPU instance that we have called the G2. That is great, for example, if you're doing any kind of GPU processing or something like AutoCAD. And then we have a micro instance. So a micro instance is something that you get for free for a year when you sign up for a new AWS account. It is not very fast, but it's great for experimenting, for just testing things out. But I would not recommend it for production. So the basic building block of EC2 instances is the Amazon Machine Image, or AMI. A machine image is just what it sounds like. It is when you launch an instance, it is what you actually launch. It has the operating system and any data that you want when the instance starts up located on it. It can be public or private, so you can take one of our AMIs. So we provide Windows AMIs and Amazon Linux AMIs, and then we have partners that provide AMIs such as Red Hat and SUSE, FreeBSD, and CentOS. And so you can take one of these public AMIs and customize it and create your own image out of that and make that your private golden image. And we see a lot of customers do that. You can also share those AMIs between your accounts or any other accounts that you wish to. And you can copy these AMIs between regions. So the other next thing that's really important for EC2 is Amazon Elastic Block Storage. If you may have noticed in the table that I had before, it lists hard disks that come with those instances. So those are called instance store. They're storage that is physically attached to the hypervisor that the instance is on, which means you can use it, and it comes with the instance, and you don't get charged anything extra for it, but it's temporary storage. If you were to shut down the instance and you were to then start it back up, you would get a whole new set of instance stores. So you should only use it for those kind of use cases, for temporary storage or for storage where you have enough replication where you can afford to lose that instance store. For persistent storage, you should use Elastic Block Store. Elastic Block Store is persistent. You can get anywhere from 1 gigabyte to 1 terabyte per volume. If you want more than that, you can have multiple volumes attached to your instances. You can do a RAID 0 across them to get one logical volume. It persists outside of your instance, so you can detach or reattach that volume to another instance in the same availability zone. You can snapshot those instances, which means that once it's snapshotted, the volume is saved to S3, and S3 is 11 nines of durability, so it's great for doing backups that way. And the EBS storage is exposed to the instances as a block device. So you can format these EBS volumes with whatever kind of file system your operating system supports. So the other thing is, in terms of performance, there's two types of EBS volumes. There's a standard EBS, which is about 100 IOPS, and then there's provisioned EBS, where you can get up to 4,000 IOPS. So with provisioned EBS, you pay for the amount of storage that you have provisioned plus the amount of IOPS you have provisioned. Now, let's talk about auto-scaling. So if you're building, for example, a web application, a web portal, a CMS, or something to those lines on Amazon Web Services, you want to be able to scale to the capacity demands of your application. So while your website may not always have a ton of traffic, there are going to be days when it does, where you got some kind of promotion going on, or for some reason your website needs a lot of capacity. So instead of being pre-provisioned, the whole time, as you traditionally have to do, what you can do on Amazon Web Services is auto-scale. So you can define a minimum and a maximum number of servers, and you can scale up and down between that minimum and maximum depending on rules that you set. So for example, you can say, I would like to scale up when my 2 servers that I have by default are at 85% CPU for over 10 minutes. Then you can launch 4 more servers. And then you can say when these the average across all of my servers that have now spun up is below 35% for 10 minutes, you can turn one of those servers off. And you only pay for what you have on per hour. So it's great for actually matching your capacity with your demand. Next thing that you want to think about when you're deploying a web application on Amazon Web Services is elastic load balancing. So on Amazon Web Services, you have the option of running your own load balancers, such as HA Proxy or any of our partner load balancers on our marketplace, such as a big IPF5 on an EC2 instance, or you could use our elastic load balancing service. Our elastic load balancing service is a cloud provisioned load balancer. It supports the routing and load balancing of HTTP, HTTPS, and generic TCP traffic if it's over port 1024. You can do SSL termination, and it supports proxy protocols. So you either have the option of hosting the SSL certificates on your web servers and having encryption go all the way throughout, or you can terminate that SSL encryption at the ELBs and have the traffic go unencrypted between the ELBs and your instances. The ELBs support health checks, so you can determine whether it's in traffic to instance or not based on the health check. That health check is going to be either TCP or HTTP. And the ELB service is itself auto-scaling. So it dynamically grows and shrinks based on the amount of traffic that it's receiving. And it's built to seamlessly integrate with auto-scaling. So you can configure an auto-scaling group of instances to automatically bind and unbind themselves from ELBs. Additionally, ELBs give you a single CNAME. So when you're referring to them, you basically just make a CNAME DNS record from your DNS, so yoursite.com, to the CNAME record of the ELB, and that way there's no single IP address or single point of failure. You can also launch ELBs both externally and internally within a VPC, so you can have an elastic load balancer that fronts some internal service that you may have. So now let's talk about database services. So you can run MySQL or Postgres or Oracle or SQL Server on your own on EC2, but we also have a managed option called Relational Database Service. So the Relational Database Service allows you to run a MySQL, Postgres, Oracle, or Microsoft SQL database that we manage for you. We manage the patching. We manage the backups. The backups go automatically to S3. With some of the engines, such as MySQL, you can also do read replicas. So you can create read replicas on the fly. And you can make those read replicas either be in the same region or in a separate region. So that's great for a DR scenario, for example. In terms of licensing, again, you can either bring your own license for Oracle or MySQL, or Microsoft SQL, or you can use the license that's included. There are now multi-Z options for actually MySQL, Postgres, Oracle, and Microsoft SQL. So multi-Z means that when you bring up an RDS instance, there's actually going to be a backup RDS instance that's brought up for you, and there's going to be a block-level replication that happens, and automatic failover if your primary instance goes down for some reason. So now let's talk about some actual deployment services. So the first thing is CloudFormation. So if you think about all these things we just discussed, RDS instances and ELBs and EC2 instances, let's say that you've built up your environment and you have all these components that you're using, and you want to be able to easily replicate it or easily redeploy it. What you can do is you can write a CloudFormation template, which is a JSON formatted text file that basically describes your infrastructure. So you can think of it as infrastructure as code, or as a text file that would basically describe and recreate a whole rack of equipment in a traditional environment. So once you write this file, you can then deploy a whole environment off of that file. So I'll give you an example. I have a customer who has open sourced their CloudFormation template. It's 4,000 lines. It deploys auto-scaling groups and ELBs and VPCs. So it's a great tool for automation. It also takes parameters, so you can use the same file for and customize it. So for example, you can launch a slightly different environment for staging or production with the same CloudFormation template. Now let's talk about Elastic Beanstalk. So if you have some kind of code that you want to deploy, say a Drupal install or some custom PHP or Ruby or Python or Node.js app or Java.net, and now actually have Docker support as well. So if you want to deploy any of these things and you don't have to worry about provisioning your own load balancers and auto-scaling groups and RDS instances, Elastic Beanstalk will take care of that for you. So you basically give it your code, and it will deploy that code for you. And after it's done, you have full control over all the resources that it has spun up. So you can SSH into the instances, you can change the parameters on the ELBs, anything like that that you would like. This is what I'm going to be doing a demo of shortly. Now, the other deployment service that we came out with last year is called OpsWorks. So OpsWorks is a DevOps service for applications in the cloud. What does that mean? Well, that means that you can define different layers in your application. So, for example, a load balancing layer, a application layer, a web server layer, database layer, load balancing layer, and you can then provision software onto those layers by chef recipes. So you either write your own chef recipes or download chef recipes online that are free and open source, and you can use those to deploy software. So what this gives you is automation. It gives you rolling deployments. You can basically programmatically manage every aspect of what's on your EC2 instances through OpsWorks, and so it's also easy to redeploy this way as well. And it's got built-in support for RDS and for auto-scaling. So let's talk about what it means to actually architect for high availability. So the first thing you want to do is you want to use multiple availability zones. It costs the same amount of money to launch 2 instances in one availability zone as 2 instances in 2 availability zones on Amazon Web Services. So you should use multiple availability zones. Availability zones are within the same region. They're designed to be on different floodplains to have diverse network and power feeds. So if there's some kind of event in one availability zone, it will not affect the other availability zones. So you should take advantage of multiple availability zones. You should ideally use Amazon RDS for your database tier. Unless you have some specific reason to run your own database on EC2, it's going to be easier, most likely, for you to use RDS. Now, if you want to have high availability, you want to be using the multi-availability zone options in RDS, and you also want to use reader replicas. So when you use reader replicas, you can offload your reads from your writes on your database, and that's how you typically start scaling your database tier. For your web servers or app servers, you want to use auto-scaling groups. So you might need 2 web servers by default, just for HA, but you might have to grow that fleet as you have more traffic. So you want to be able to grow it and shrink it based on your actual demands. You want to put an elastic load balancer in front of the web servers. So you want to distribute traffic to all these instances that you have with an elastic load balancer. So let's talk about some of the configuration options out there that you can use on Amazon Web Services. So there's a lot of configuration management systems out there. There's Puppet and Chef and SaltStack are pretty common ones. Some, I know Puppet and Chef, for example, work in Windows as well. So they're all really popular. They all have their pluses and minuses, but all these are great for automation for basically taking all the manual tweaking out of configuring your EC2 instances. Then there's deployment frameworks. So deployment frameworks actually help you deploy your code onto your instances. So we're going to talk about Elastic Beanstalk. I've showed you what OpsWorks can do. Some of the other options out there are Ansible is a really popular one. Fabric is a deployment tool written in Python that you can use. Capistrano is another deployment tool that's very common with Ruby developers. And then there's CloudFormation, which is infrastructure management. So it's not just worried about what's on your instances, it's also working with what's in your whole infrastructure. What about your load balancers, your databases, your VPCs, all of that. So with that, let's do a live demo here. So what I'm going to show you is how to deploy a basic Drupal install on Elastic Beanstalk. So I already have one running here from before, but let me show you how to do a new one. So we're going to create a new application. I'm going to call it Leo's Demo Drupal. I'm going to select which programming or which tier I want. So I want web servers. You can also configure workers, which talk to SQS queues, which is another sort of template on here. I'm going to choose which language I'm using. So I'm going to be doing PHP since that's what Drupal's written in. And then I'm going to choose, do I want just a single instance or do I want load balancing and auto scaling? And since we just talked about high availability, I definitely want load balancing and auto scaling. So now I'm going to choose what application do I want to deploy in here. So I've just taken the Drupal zip file from their website, and I'm going to deploy that on here. So I'm going to go ahead and upload my sample application. So now I'm going to just name my environment. So Leo Drupal prod. I'm going to see if that's available, and it is. And I'm going to choose to create an RDS instance because I want a database with this. So now I'm going to choose what instance size do I want. So I don't know yet. I'm not 100% decided what I need, so I'm just going to choose an M3 medium, which is a good general purpose instance size. I'm going to choose my EC2 key pair. This is my SSH key pair that will allow me to basically SSH into these instances after they're created. I'm going to choose an email address where I'm going to get notifications about my application. So I'm going to put in my email address, and then I'm going to hit next. So here I could tag my environment. So it's really important to tag your environment. So I'm going to give my environment name, say Leo's Demo Drupal. Oh, name is a reserved one, so I'm going to application. Let's call. There we go. So now I'm going to choose some options for my database. So I have all these options for which database engine I want to use. I want to use MySQL. I'm going to choose which size of instance I want. Again, I'm going to go with an M3 medium. I'm going to go with just 5 GB of storage. I'm going to do a username and a password for my database. And I'm going to choose to have multiple availabilities again because I want this to be highly available. So now it's just helping me review my options. And it's launching my environment. So while that's going, let's take a look at the environment I just launched recently. So here, once this is done, this is what this would look like. So here's my environment. And this is just your standard Drupal install. So let's go ahead and just choose our options here. So I'm using MySQL. I'm going to fill in all this stuff here. Now, I also need to get the name of my database because I don't want it to be localhost. I'm using RDS. So I'm going to go to configuration here, and here's what it named my database. So I'm just going to copy and paste that in here. Oh. See if I got my username right. Well, it looks like I forgot my username that I set up earlier, but assuming I had this username correct, here's what it would look like afterwards. This is a fully installed Drupal environment here. So then now I have 2 environments here. So I have my production and staging. So another cool thing that you can do here is, let's say I wanted to do an update. I'm going to a new version of Drupal. So since I have 2 environments, I could update it on staging. So you can deploy a new version of Drupal, for example, if you have it. And what you can then do is, after it's deployed, I've got it running here, my new version, my old version, and I can actually swap the URLs. So I can take my staging environment and swap it with my production environment. And so the URL for this will now be the URL for that, and vice versa. And I will have updated my code, and I can easily roll back as well. So there's no risk of, or there's little risk of anything breaking, and if it does break, I can swap back. So that's how to do this through Elastic Beanstalk. Now, just to show you, how would I do this manually, right? So I've spun up an EC2 instance here. Let's just launch a new one so I can show you how to do that. So I go to Launch EC2 Instance. I'm going to pick my image here, so I'm just going to use standard Amazon Linux. I'm going to pick my instance type, which I want M3 medium again. I'm going to pick, I want it to have a public IP address because I want it to be internet accessible. I want some detailed mothering because I want to be able to see what it's doing. I'm going to choose the default storage configuration here. I'm going to name it Leo's Demo Drupal. I'm going to give it a new security group. I'm going to open up SSH access from anywhere, so let me do that. Now, typically, when you're doing this in a production environment, you don't want to open up SSH from anywhere. You want to just open it up from your own IP address. So you choose my IP in here instead. Then I'm going to open up to HTTP traffic from anywhere. So here's all my options that I've chosen. And now I'm going to just choose my key pair here. And my instance has now been launched. Now, let's go back to my instance that I launched earlier and see how to manually install Drupal. So here's my instance from before. I'm just going to copy the IP address. I'm going to go to my terminal window here. I'm going to SSH into it. What you want to do is, since it's Amazon Linux, I'm going to SSH into it as the default user, which is EC2 user on here. There we go. So I'm in my instance now. So now I'm just going to go and download Drupal. So Drupal. So I'm going to get the latest version here. Get it. So now I'm going to become root. I'm going to go to the, so now next I need to install Apache. So since this is Amazon Linux, I'm going to have to manually install Apache here. I have to install MySQL, and I'm going to have to install PHP MySQL, which is the PHP MySQL binary. So I've now installed all this stuff. Now I'm going to have to make sure that MySQL starts on default. Oops. Oh, I forgot to install. I'm going to have to install MySQL Server as well. So, there we go. So now MySQL is going to start by default. When I reboot my instance, I'm going to have to do the same thing with Apache. So now I'm going to have to initialize my MySQL. All right, I'm going to have to set up my password for MySQL by default. So I'm going to give it password. Sorry, I'm just running that one more time. I'm going to set my root password. All right, just going to go through all this stuff and say yes. So now my MySQL is all set. Now I'm going to have to install or get my Apache server started. All right, and now I'm going to have to go to my web root and unzip my Drupal in here. So all right. I'm moving my old HTML directory to the old one. I'm going to move my Drupal to my new HTML directory. All right. So now, let's see if I'm just going to change permissions. So the HTML directory is owned by Apache. Oops. All right. So now let's see if I can get to my Apache install script. Do one more thing here. All right, so getting the default page here. So what I'm going to do is restart my Apache. Yes, so shouldn't have to go and change my, so you can see this a lot more involved than Elastic Beanstalk. I'm going to have to go change my configuration. So that it reads my index for my Apache. So go. See if that works. Oh. All right, well, my Apache still isn't working, so there we go. So assuming this works, I would have gotten the same install screen. But as you can see, this is a lot more complicated and a lot more involved than just going to Elastic Beanstalk and launching the environment from here. So there we go. So that was my demo. So I think we're going to bring it over for questions now.
Okay. Thank you again, everyone, for staying on board with us as we did a couple of demos or a demo and you know, just kind of a brief overview of the services. Kind of what we're going to switch into now is kind of what I mentioned at the beginning of the webinar, and that is that kind of the Q&A session. But before we start that, I have a couple of polling questions I wanted to ask you. Kind of what we do as an organization and how we iterate and grow is based on the feedback of our customers, and that includes these webinar series. You know, we develop these for your benefit, and if we're doing stuff that's right, we want to keep doing it. If we're doing stuff that's wrong, we want to get rid of it. So our feedback from you is very important. So to kick that off, there's going to be 3 questions. We'll do about 30 seconds on each. While you're looking at those, which will pop up on your screen, please you know, don't hesitate to take some time and send in some questions. Like I said, we'll answer as many as we can in the time allotted. Otherwise, with any that may run over time, we can follow up with you offline and in the background. So with this, we'll go ahead and start the polling session. All right, thank you, everyone, for all of your feedback. We appreciate that. Of course, any other you know, again, questions or feedback that you have, please don't hesitate to send them through the question section of your console or through the chat window that you can interact with us directly. One thing I wanted to mention really quickly before we jump into that is the save the date that you see in front of you, and that's for our Government Education Nonprofit Symposium that's here in Washington, D.C. at the latter part of this month. It's no cost to attend, but is a great way to leverage your peers, as well as those in a couple other verticals, and find out how they're leveraging AWS. What roadblocks have they hit and that they've overcome? What successes have they found on various use cases? And then, of course, a number of different topics that are going to be led in different various sessions where you can learn more about what AWS and our customers are doing. Take some tricks of the trade and take them home and figure out how to apply them to your own organization, your own workloads. So I wanted to make sure and mention that. Now, with that being said, we'll go ahead and jump into the questions. So we had one that came in here just recently that I want to go ahead and start out with. So when you save an AMI image, okay, so these golden images, these templates, how do you set it up so that it will take a password you send the build from in the command line, the CLI? It seems like the settings change or alter whenever you're trying to save it.
Okay, so if I understand the question correctly, basically what happens is when you launch an instance of an AMI, there's an option in there that I went through when I launched the instance where you choose the key pair. So the way that it's set up is that key pair that you choose gets injected every time the instance is launched. So if you take an image so you have an AMI and you say share it to another account, that account, when they launch that AMI, they have the option of injecting their own key pair into it so they can log in. Now, if you want to go beyond that, though, your image can, for example, be configured to connect to an Active Directory or an LDAP server, so you can use that for authentication instead. Or it can have pre-built users, like if it's a Linux instance, just pre-built Linux users where you can, they each have their own keys already associated with it. So that would be how you would, have pre-built passwords in there. But when you the AMI itself actually doesn't have a password associated with it. It's locked down by default to your account, and you then choose to share it or not with other accounts.
Okay, awesome. And just a couple more here that we're going to go through. When it comes to auto-scaling, we mentioned that earlier. That's great. That's kind of taken off the table in terms of having to worry about manually going in there and checking the boxes as far as pulling resources down and then raising them up. But in times when things get a little chaotic, that can be a little unnerving, we'll say. So what options do you really have out there as a user of AWS to set a lot of those auto-scaling rules, and kind of what does it look like?
Yeah, so the way that auto-scaling looks like is you first have an auto-scaling launch configuration. So what that is a feature set where you can choose to configure what does my auto-scaling group look like? What instance type is it? What image does it use? What key pair is there? And so you configure launch configuration, and then you configure your auto-scaling group. And your auto-scaling group is tied to a launch configuration. It's also tied to scale up and down policies, and those policies are policies that can, for example, you can have a policy that says double my number of instances, or cut my number of instances in half, or add 30% more instances, or just add 5 more instances. So you can have policies, and you can either manually execute those policies. So if you know you're going to get traffic, you can preemptively scale. You can say, at tomorrow at 7 a.m., I want to execute my double my capacity auto-scaling policy. So that's ideally what you want to do. If you know that you have traffic incoming, you want to preemptively scale, so you don't have to wait for it to automatically scale. However, sometimes you don't have that luxury when you have traffic that's spiky, or something's gone viral and hit your website. So in that case, what you want to rely on is your CloudWatch alarms. So CloudWatch is our metrics service, and so you can there's a bunch of metrics that are included. So like CPU usage, or queue depth, or network throughput. It just depends on the service, whether it's EC2 or RDS, what the metrics are. Additionally, you can also inject your own CloudWatch metrics. So if you want to scale off of something like how many tweets is this hashtag getting, you could write a custom CloudWatch metrics that keeps track of that and have an alarm based on that. So what happens is you have all these metrics, and then you set it so that when the metrics hit a certain threshold, they alarm, and that alarm kicks off your scaling up or scaling down policy. Now, there's a bunch of other things you can actually do on top of that to absorb the load. So before you, let's say with an example with a Drupal install, you've got your instances behind your ELB. And you definitely want to scale those up and down based on the traffic. But what else you can do is you can put our content delivery network, which is called CloudFront, in front of your Drupal install. What that will do is that will distribute a copy of your website to our over 50 edge locations around the world. So when users go to your website, they'll actually be most likely hitting an edge location and not your instances. So that'll absorb a ton of the load. It'll cache what's cacheable and pass back the dynamic content to the origin. So that'll greatly reduce the load off of your website. So that's another really good strategy to use. On top of that, you can use Route 53, which is our hosted DNS service. So you can have, let's say, a copy of your website on the East Coast or on the West Coast, and you can route traffic based on latency to two copies of the website. You can have a failover scenario where if one of them is down, you can go to the other region. You can do A/B testing, so you can have two copies of your website, and you can have 20% traffic here, 80% traffic there. So there's all kinds of options out there for spreading out the load and making your website more scalable and automatically scaling up and down.
Okay, and we've walked through a CMS scenario where we're either launching it through something like Beanstalk or we're doing it manually, and that's all well and good. But what if I just have a simple static website? Just want to put up there. What does that look like?
Yeah, the best practices for that would be to just host the static website on our Amazon S3 service. S3 stands for Simple Storage Service. It's got 11 nines of observability. It is a regional service, so you don't have to worry about availability zones. You can just pick which region you want it in, and it supports the hosting of static websites. So all you do is you create a bucket. You enable that bucket for static website hosting. You pick, what your index is and what your error document is. You upload your content on there, and you set a bucket policy that allows the public reading of the files in there. And that can handle a lot of traffic. The other thing that you can do is you can actually put CloudFront in front of your S3 bucket. So you can have a CDN in front of it. So not only do you get the high availability of S3 and all the benefits of it, and you don't have to pay for instances, you're just paying for storage and outgoing bandwidth, you can also have it so that you get the low latency benefits of using CloudFront.
Okay, and again, we mentioned earlier about the different ways to deploy some of these environments. Right? We talked about Beanstalk, we talked about OpsWorks, talked about CloudFormation, and they also may be very helpful in terms of easing the pain of going in and manually deploying a lot of these things. But at what point does it make sense to use each one of them as far as a differentiator? Sometimes it just gets cloudy in terms of where to go.
So I would say in terms of Amazon Web Services, provided services, if you want to kind of be hands-off and just have some code that you want to deploy and not have to worry about load balancing or tweaking any of that stuff, I would do Elastic Beanstalk. It's very simple. You just upload your code, you specify a few parameters, and it deploys everything for you. If you want to have a little bit more control over the settings, then I would use OpsWorks. So in OpsWorks, you can completely tweak like what web server is being installed, Nginx or Apache, anything that a chef recipe can do, which is basically, it can affect any part of the operating system, you can tweak. So you still get the benefits of configuration management on automation and automatic bootstrapping, but you get more flexibility and more control than you would with Elastic Beanstalk. But that may be a plus or minus depending on what your business needs are. Then on top of that, you may have a lot of experience with something like Puppet or SaltStack, and then you can manage your own Puppet or SaltStack servers on EC2, and you can configure that way. I mean, I've even seen users who just have shell scripts that basically do something really simple to just pull code off a Git repo. That's certainly something that works as well. So there's no right or wrong answer to that, but it just depends on what your skill set is, how much time you want to devote to configuration management, and where do you want to kind of focus your time. So I would say that to me it seems like you want to work on what differentiates your business from other businesses in your field, and kind of take off a lot of the heavy lifting that you would normally have to do. So that's what makes things like OpsWorks and Elastic Beanstalk so attractive.
Awesome. Now, we talked about auto-scaling earlier and how that kind of works, and that's great. Again, having all these services that help with that, or just kind of setting it up ourselves and having that run in the background. Do you have to do that at the beginning, or can you? Are there certain points where you already have an environment set up and you can have that then added to it, or how does that work?
Yeah, you can set up auto scaling at any point. All you really need to do to have auto scaling is some kind of image to deploy. I would say from a best practices perspective, it's definitely better to set up auto scaling. Kind of think about how your application is going to scale from the very beginning, because it's a lot easier to do it at the beginning than once you have a full architecture configured, and it'll be a lot more work then typically. But that being said, we definitely have customers who just, as the first step, they lift and shift their application as it is onto Amazon Web Services, and once it's there, they start picking off pieces of it that they can optimize, such as adding auto-scaling, utilizing S3 where you can, utilizing CDNs. That's a valid pattern of migration as well.
Okay, great. Now, just in general, are there any gotchas or things that are just kind of general, hey, watch out for these types of things when you are operating either with auto-scaling or deploying some of these types of environments, just general best practices of things to be aware of when delving into this?
Yeah, so the first thing that you want to watch out for, you want to architect for scale and high availability, like I said, from the very beginning. What that usually means is you take a look at your architecture and you look for single points of failure. Because you might think of almost everything, but if you have one thing that if it fails and everything depends on it, your whole application will fail. You want to make sure you find all those things and mitigate them. So, for example, you want to take a look at, are all of my instances in multiple availability zones? Are there 2 of everything? Is my database multi-availability zone? Do I have a way to fail everything over? What happens if my master database server crashes? Maybe I should use queues or something, as a in between the database and the app server or the web server. Do I have a load balancer that can scale? So you want to think about single points of failure and how to avoid them. The other thing that's really important is as you build things for scale, you don't want to have to manually tweak anything. So you want your instances to come up and bootstrap themselves and come from a unconfigured state to a configured state where they're ready to accept traffic as fast as possible. So it might be doable to manually tweak a few instances if you bring them up once in a while, but if your application grows to tens of instances or hundreds of instances or maybe thousands of instances, that's going to quickly not become scalable. So you want to automate everything. You want to think of your infrastructure ideally as ephemeral. So if you look at your setup and you say, okay, I'm going to randomly kill an instance here. If that doesn't break your architecture, you're probably well architected. If it does break your architecture, you should think about how do you avoid that? How do you automate everything?
Okay. And then just again, kind of on that same topic, what limits do I need to be aware of in terms of, hey, I can't predict my traffic a lot of times in certain periods. How high it's going to get a lot of times. There's certain ways that I can be self-prescriptive in trying to figure that out. But if we get a heavy hit day, we become insanely popular and everything's coming in all at once. What do I need to be aware of, especially ahead of, like, let's say, a production launch?
Yeah.
Right? So what kind of limits do I need to be aware of?
Yeah, so there's just some, when you have a new AWS account, there's some default soft limits on your account. For example, you get 5 elastic IP addresses and 20 instances, and that's the limit. Those are all soft limits, so you can get those raised. So you just fill out a form on our website. It's under actually support. You can go fill out a ticket, and your limits will get raised. You want to make sure that all those sort of limits are taken care of. There's a hard limit of 100 S3 buckets per account, but that shouldn't really be a problem if you're well architected. But I would generally say if you have a launch, you should talk to your account manager and your solutions architect, and have them just work with you to kind of figure out what the possible limits are and how to how to make sure you don't hit them or get those limits raised.
Okay. And just a reminder out there to everyone, we're still taking questions. We've got about 10 minutes here left with the webinar. So as you kind of raise either figure out some questions from some of the topics that have been mentioned so far, bring them in. If you've got some things on the brain of some possible workloads or things that may not necessarily be applicable to the example we provided today, we'll also field those. Feel free to, again, enter those through the question portal on your dashboard or through the chat window that you have available to you. Those will come straight to me. In the interim, kind of while we're filling some time here, ahead of other questions coming in, what else can you tell us about how to really, utilize kind of the console to everything that it can? I mean, we went between the console and the CLI, right? Mm-hmm. Some of us live in the CLI. Yeah. Others can't even stand it. Mm-hmm. So are there certain services that we've mentioned today that only operate within the CLI, or ones that you can still use, you can kind of trade between both depending on what you're comfortable with?
Yeah, everything we've used today, you can trade with both. Okay. So, but generally, typically we come out with both a console and the CLI at the same time. But the CLI, there's always a way to access all of our services through either the CLI or an API. That is so that you can automate everything and program against it, write code against it. So we tend to, always have an API and the CLI available, and then the console, shortly follows or is released at the same time. Now, I'm personally a CLI person, so I find that it's easier, for me than pointing and clicking to be able to script everything, to be able to use a terminal. I can work more efficiently and faster that way. But typically, as users start, they definitely tend to use the console as it tends to be more user-friendly for new users.
Okay. Now, also, just kind of one more question on the back end before we get any more. One thing that's kind of been mentioned in a lot of use cases with AWS is, okay, great, I can auto-scale this, I can set this all up, I can get this all moving. Wonderful. I do have a budgetary constraint. Right? Mm-hmm. I want to make sure I'm operating within that, and I'm aware of that. Are there any kind of notifications or alarms or things that I can set up when these things auto-scale and the like, so I can be prepared to adjust on the fly to any of those kinds of constraints that maybe business side or organization side compared to just traffic?
Definitely. So the first thing is that when you're configuring auto-scaling, you can get it to send you notifications when it scales up or down. So that's part of the simple notification service. So you should definitely configure that so you know when you're launching or taking down instances. Additionally, in terms of billing, we have an option called AWS Billing Alerts. So you go to CloudWatch, and under CloudWatch there's a tab called Billing Alerts, and you can configure it to send you a notification when your bill becomes greater than X amount of dollars, whatever you configure it to be. Additionally, you can also, in CloudWatch, there's a bunch of billing metrics that you have access to, so you can see what your estimated bill is if at the end of the month for today. Now, another really important option to take a look at is to enable the detailed programmatic billing. So what that does is it drops text files with your billing data by the hour into an S3 bucket. You can then take that data and either look at it in something like Microsoft Excel, or you can use a partner application. There's, for example, a plugin for Splunk to take a look at that. To take a look at your bill, there's an open source tool by Netflix called ICE that takes a look at that, and that will let you look at your bill and make optimization decisions. So you can see, oh, well, I've had this thing running for a month and I don't really need it anymore. Or, I should probably buy reserved instances for this set of instances because they're running all the time. The other thing that's really important for cost optimization is to tag everything. So as you saw when I was launching things on Elastic Beanstalk, there's a tab in there called tags. So the more you tag things, the more you can figure out what they are. You don't want to take a look at your EC2 screen, for example, and see that everything's untagged and have no idea where anything is beyond an instance ID. And you can then tie those tags back to your billing report so you can see, for example, if you have a tag for application name, you can see how much did this application name cost me, whether it's EC2 instances or S3 bucket objects or RES instances. So it'll help you figure out what's going on in your account a lot quicker as well.
And one last question. I want to back a lot of this stuff up, right? Whether it be in the AWS cloud or just on-premises stuff, because I know S3 and Glacier and things like that are cheap, right? It's great, it's robust and the like. What does that look like? I get it in the console. I can manage that and kind of have it all communicate. But what if I have some on-prem or colo type stuff that I also want to back up? What does that communication channel look like between us and AWS?
So the first thing that you can do is you can use our command line interface to talk to S3. So you can back up from anything you have on premises into S3. You can then have lifecycle policies on your S3 bucket. So you can say, okay, after this backup has been in my bucket for a month, I want to put it into Glacier, which is our long-term archival service. So you can configure backups like that, and that's a really good way to do it because it's distributed, so you have each of your servers backing themselves up. There's no single point of failure. You're going directly to S3, so it's really economically efficient. Another thing that you can do is we have something called an AWS Storage Gateway. So what that is a VM that you install on your local environment. It's either VMware or Hyper-V. It presents your local environment with an iSCSI endpoint. You can then take that iSCSI endpoint, mount it, make it a CIFS or NFS share, or however you want to provision access to it. Anything that then goes into that endpoint is backed up to the cloud. So depending on what kind of storage gateway you're setting up, we have a virtual tape library one or we have a standard one. You can back up either into Glacier or S3 or EBS volumes. So that's a really good way to get some on-premise stuff into Amazon Web Services backups. Another option is we also have a bunch of partners that provide actual physical appliances. They do basically the same thing as the storage gateway, but in a physical appliance form.
Great. Thank you, Leo. And with that, I think we'll go ahead and close the Q&A session. You see our information up there on the screen. Leo, of course, who is kind enough to present today, who's a solutions architect, and then me, Michael Landis, who's an account manager here at AWS. Should you have any questions, whether they be business or technically related, feel free to reach out. We're just an email away, and we'd be happy to assist you with whatever you got. Just as one parting shot, I just want to remind you again of our symposium that's going on here towards the end of the month. We highly encourage you all to come. It's a great forum for you to share your experiences, not only with each other, but with us, so that we can continue to iterate and improve our services to you all. So thank you again for taking the time to get on this call, and we hope you have a wonderful rest of the day and weekend. All right, take care.